Well, so welcome you all to the next video lecture on basic electrical engineering. So today actually I would be discussing few numerical related to DC machines. So I would be starting with a numerical on DC generator, and then gradually I would be moving on to a problem related to DC motor. Now starting with the first problem. So what it say that we are having a DC generator that is delivering 45 ampere to the load. So load is connected over here, and we are having shunt generator. So this is the arrangement. We are having the shunt field in parallel. It is given that the terminal voltage will be 220 volts. So the VL will be equal to 220. Armature resistance RA will be 0.01 ohm, and shunt field resistance will be 44 ohm. We have to find out the efficiency of the DC generator. And what is also given that the total stray loss should be equal to 375 watt. So let's see how we are going to proceed for it. So from the data, what we could see here is that the VL is equal to 220 volt, and that VL is actually applied across the shunt field. So the shunt field current ISH will be nothing but VL divided by RSH, because this voltage will be 220 and the shunt field resistance will be RSH. So this should be coming to be equal to 5 ampere. 220 by 44, it is coming to be 5 ampere. So 5 ampere current will be passing in this direction, IL will be passing in this direction. And what about the armature current IA? So from that we could say that IA will be equal to IL plus ISH, that will be equal to 50 ampere. So this is the current that is actually produced by the generator. Now once we are knowing this one, so what about the generated voltage EG? So what we could write, generated voltage EG will be equal to the drop in the armature plus the supply voltage. So if I am applying the KVL in that equation, from that we could write EG will be equal to VL plus IA RA. I am neglecting the voltage drop which may be occurring in the price because no data is given. So for whatever data is given, so from that we could write it would be something like this one. So putting all the value, VL is equal to 20, IA equal to 50, RA equal to 0.01 ohm. So from that what we could write is that the value will be equal to 220.5 volt. That is the value what is going to have the EG would be. Now if we are having the value of EG, alternatively what we could do, we can find out the total power generated. That would be nothing but, so what we could say that this PG, the power generated, will be the product of EG into IA. So that would be coming to be 11025 watt. That is coming to be. Now how it is coming, we would be again proving it in a different way, but in that way also we could find out that what is the generated power. Now what is given, that the stray loss is equal to 375 watt. And what are the other losses which may be occurring in the machine? The copper loss. Now, so what would be the total copper loss that would be occurring in the machine? So this PCU will be what? That would be the copper loss occurring in the armature and the copper loss happening in the shunt field. So it would be nothing but, it would be IA square into RA plus ISH square into RSH. So we are having copper loss in the armature, we are having the copper loss in the shunt field. So from that what we could say that that would be coming to be equal to 1500, sorry, it would be coming to be 1125 watt. We will be putting the value and calculating it, we will be getting something like this one. So this is the copper loss occurring in there. And what is given, the stray loss is given there. So what will be the total loss occurring in the machine? the total losses, P loss say, that would be this PCU copper loss plus stray loss. So this plus this, that would be coming to be 1500 watt. Now, what is the output power? Output power is basically the VL into IL. So the output power or load power would be nothing but VL into IL. So what is the value it is? It would be coming to be 9900 watt. Now once we are knowing this load power and once we are knowing the input power, or other way we can find out the efficiency, that would be the output power by output power plus losses. So that would be P loss into 100. Now we know PL, we know P loss. So putting all the things together in this formula, we are going to find out the efficiency, that would be coming to be 86.84%. So that is how basically we could find out efficiency of a DC generator with the given data. So hopefully you can understand that how basically we can do the thing. Now let us go to the next problem. Okay, so the next problem is related to DC motor. So what is say that I am having a motor. It is 220 volts, so the input voltage will be 220. 10 kilowatt, the output of motor will be 10 kilowatt. 900 RPM, this is the rated value of the machine, and it's a separately excited DC motor. So separately excited DC motor means the shunt field would be supplied by a separate source as given. And whatever voltage we are giving to 20 volt, we would be giving it to the armature. What is given? The armature resistance is given to, that is equal to 0.02 ohm. Now what is given? That when the motor is operating at a rated speed with the rated terminal voltage, the torque is this one. Now if we are neglecting the rotational loss, we have to find out what will be the current drawn by the motor under that condition when the supply voltage is 220 volt. So we have to find out what will be the value of IA. So all the values what are given, VL is 220, speed is 900 RPM because the motor will be running at the rated speed, and the output torque is this one. Armature resistance is given to us. Now it's a motoring mode. So what is going to happen, that we are not having the generated EMF, we are going to have the back EMF, EB. So what we know, that our back EMF EB will be nothing but the supply voltage, say Vs, minus IA into RA. Now Vs is given, that is 220, minus IA we have to find out. So it would be IA into resistance 0.02 ohm. So this is the value of EB, what it's going to be. What we have to find? We have to find out IA. Now let's see from the given data what we can do or how I could do. What we know that the output torque will be equal to power by omega. So what is going to happen? It would be power by 2 pi n by 60. So we know this equation. So from that what we can write? We can write that the power will be what? Power will be 2 pi n by 60 into T. Now, what about this power? The power in a DC motor, in this particular case, we can say that this power will be nothing but this back EMF into IA will be the power, so that is going to be this one. Now EB, we know this is the expression, so putting it over there, what we are going to have, 220 minus 0.02 IA into IA will be equal to, now if you are going to put all the values, they should be coming to be equal to 6600. So what we can write from this equation is, we are going to have a quadratic equation now, IA square minus 220 IA plus 660 equal to 0. So I am having a quadratic equation now. So you have to solve this quadratic equation to find out IA. So if we are going to solve it, we are getting two value of IA. One value of IA will be 10969.92 ampere and 30.08 ampere. So of the two, this value is quite large. So we are going to ignore the value. So the value of IA will be equal to this one, and this one will be the appropriate answer for it. Okay, so now come to the third problem, that we are having a series motor now, 200 volt DC series motor, and it is delivering some load at which it is drawing 10 ampere of current and running at 1000 rpm. And we are assuming the magnetic circuit to be linear. So if we are increasing the current, then the flux inside the machine is going to increase. We have to find out the speed of the motor when the load torque increases by 44% for the same supply voltage. This is what is given to us. So now try to understand what is given. It is given that the total series resistance is equal to 1 ohm. So what is going to happen in this machine? The series resistance and the armature resistance, they should be in series. So the combination of the two, RA plus RAC should be equal to 1 ohm, that is given to us. Now, initially, what is given? That the armature current IA equal to 10 ampere, for which the speed is equal to 1000 rpm and the torque is equal to, say, T. Okay, this is given. Now what is being said? That when there is some current IA2, then this torque T2 increases by 44%, so it is going to have 1.44 T. For that, we have to find out the speed. So we have to find out the respective speed, that is what will be the value of N2. This is what we have to do. So let's see how we are going to move. In case of a DC motor, what is going to happen? N will be proportional to EB by phi, and phi will be proportional to IA. So what we could write, that would be equal to EB by IA. And what is going to happen with the torque? Torque will be proportional to phi IA. So therefore it is going to becoming something like that. So torque will be the square of IA. So we know T1, we know T2. So from that what we can write? we can write that T1 by T2 will be equal to IA1 square by A2 square. So from that, A2 will be equal to, IA2 would be equal to IA1 into root over 1.44. So 1.44 is basic root over would be 1.2. So that would be coming to be 12 ampere. This should be the value of IA2. So we had found IA2 now. So IA2 is known to us now. What we have to find? We have to now find the speed. So what we could write there, that N2 by N1 will be equal to EB2 by IA2 into IA1 by EB1. So if I could write it like that, so what is basically back EMF? Back EMF would be nothing but that will be equal to the supply voltage Vs minus IA2 into this total resistance, let us say RT. So this should be this RT divided by IA2. IA2 is given, that is 10 into 12 by Vs minus IA1 into RT. So we are putting all the values and then we are finding out the value of N1. So if we are going to, we know the value of N1, we have to find out the value of N2. So if we are putting all the value and simplifying it, so we are getting N2 would be 824.56 RPM, that is approximately equal to 825 RPM. So this is what would be the value of the speed when the torque increases by 44%. So this is how basically we are going to solve it. Now let us go to the next problem.